All right, complex fractions. Basically, and all of the complex fraction is, it's a fraction inside a fraction. It's a double-decker fraction. You know, to borrow from the Lego movie there. That you're going to start off with. Let's just show you one here to start off with. You'll have something like this. So you start off with x over x minus 3, and then somewhere in there you're going to have the big part of the fraction bar and the over, so that's the numerator, and then your denominator is x squared over x minus 3. Okay, and the biggest thing that you want to do with your complex fractions is you want to rewrite these using the KCF method, where you're going to keep it, change it, flip it. So when you see this problem, you really have to think about it as being x over x minus 3. When wherever that big fraction bar is that you have, that separates the numerator and the denominator, that's where you're going to go back and rewrite that as divided by, and then x squared over x minus 3. So really it's more rewrite than use KCF. So rewrite it with your division symbol. And then use keep, change, flip it to make it into a multiplication problem. And then once you've done that, then you factor and cancel. I should have done a better job of getting this in here. So let me go back and do that. Squeeze it in too tight there. Okay, so complex fractions. Biggest thing you have to do is rewrite it with your division symbol, use keep, change, flip, and then you factor and cancel. Now, they'll get a little bit more complex, but that's pretty much the basics of everything that we're going to do. So we've got x over x minus 3 divided by x squared over x minus 3. Keep it, change it, and flip it. Okay, so now we've got x over x minus 3 times x minus 3 over x squared. Okay, so we keep, change, flip, we got it here. Now, from this point you factor it. There's really nothing for this one that you can do to factor. So it's pretty much stuck. You can start canceling because you've got the x minus 3's that's in top and bottom here, so you can cancel those two parts out. You've got x to the first over x squared, so you can cancel out one of the x's here and one of the x's here. Knock that down to x to the first. So if we go back and put 1s for everything that we cancel here, you've got a 1 on top and then 1 times x to the first power, or just 1 over x in the bottom. All right, let's give you another one that was just so we can kind of see what's going on here. And they'll mix these up. There's not any one particular rhyme or reason for any of these, so they'll give you all kinds of different looks when it comes to these parts of the fractions that we have here. Okay, so we've got x minus 7 over x minus 2. Then we've got the big part of the fraction bar, which separates the numerator from the denominator. The denominator, then we've got x minus 7 over 2x to the 7th power. Okay, now, and again, if you get good, you can kind of combine the two parts together. But, you know, for what we're doing, I'm going to slow it down so we can take it one piece at a time. Right, and then we'll keep, change, flip. Times x over x minus 7. Okay, and again, the only little small thing I would say on this one that you might want to do is anywhere that you have x pluses and x minuses, you might want to put some parentheses around them, just to be on the safe side. That you can cancel out the x minus 7's. That leaves us with 2x to the 7th over x minus 2. And again, don't cancel the x minus 2 because technically that's in parentheses, so you cannot cancel those 2's. Because again, technically speaking, that x minus 2 that does have the parentheses around it. So that's as far as you can take that one. Okay, so biggest thing on that one is, again, just realize that when you do, now they may take a different look at it, but to me that's always kind of been the easiest way to look at one of these problems, is that if you rewrite it as an actual division problem that's here, use keep, change, flip to change it to a multiplication problem, then it's just cancel. Factor it out, cancel it. Now again, we'll get to the next part where you actually have to do some factoring, but this one was pretty much just a cancel, but it's always those same kind of steps as you go through this. Okay, objective number 2, still pretty much the same thing. It's a complex fraction, and they're just going to tell you to simplify. So 4x plus 16 over x over 8x plus 16 over x to the 5th. Okay, now, again, if you do enough of these, if you kind of you know what's going on, this is maybe where you could save just a little bit of time. If you want to go ahead and change this thing to multiplication, just realize that on the bottom part, you've got to flip this thing upside down. So that would be x to the 5th on the bottom, and then 8x plus 16 when you flip this thing over. And you could almost do it this way. You could almost just do keep, change, flip like this right down the side. And that way you know, all right, I'm going to keep this, I'm going to change this, and then I'm going to flip this fraction. So if you want to do that, it does save you a little bit of time, so you don't have to write it out so much. Okay. From there, you do have to factor. So you've got 4x plus 16. You can factor out a 4. X to the 5th is pretty much stuck. Nothing you can do with it just yet. 8x plus 16, you can factor out an 8. 8x plus 2. Okay, really close on that one, but that's x plus 4, x plus minus 2. So there's nothing parentheses-wise that you can do. But you can factor the 4 and the 8. You can divide both of those by 4. Make that a 1 and a 2. And with the x and x to the 5th, again, that is x to the 1st and x to the 5th. So you can cancel out one of these and cancel out one of these to make that x to the 4th. Okay, not as much as it was in the past, but you do have an x plus 4. You've got an x to the 4th. On the bottom, we've got a 2. And then an x plus 2. Okay, and again, order-wise, where you put which one first, it doesn't matter. As long as you've got what you need in the numerator and what you need in the denominator. Same thing with this one. You could have taken the 2 and moved it to the end and still been okay. But we're just used to seeing it in the front, so we'll leave it in front. Same thing with x to the 4th. You could have moved to the front. But that one would be your final answer there. All right, one more of those. Okay, and again, if you want to save a little bit of time, let's go ahead and do keep, change, flip, just right down the line. So we know we're going to keep the 5x minus 30 over 2, change that division to multiplication, and then flip this one upside down. And again, factor everything out as much as you can. Numerator here, you can factor out a 5. And that's the only thing. Everything else is pretty much like it is. Okay, and again, with the x minus 6, if you want to think about that one being in parentheses, you can. You can cancel out those x minus 6s, so those are out. With the 2 and the 12, you can divide those both by 2. So at the end, we've got 5 times 6 for 30 x. And on the bottom, there's just a 1 times, we got 1. So there's really nothing in the bottom left over other than 1. So for that one, it's just 30x. Okay, so first two objectives, again, it's just rewrite it, keep, change, flip it, do a little bit of factoring, a lot of canceling, and then whatever the answer is, that's what the answer is. It does change gears just a little bit when we get to objective 3. Because on objective 3 now we're still doing the complex fractions on this one, but this one says that it changes because it now has sums of rational expressions. The first two is pretty much, here you go, just work out the greatest common factor, just work out the complex fraction. The last two, they change it where you're dealing with sums of rational expressions. So it does change the problems just a little bit when you go through these. Okay, and this one, you've got two different approaches that you can take when you go through this one. And I'm going to tell you the one I like, just because of how it sets up this thing. And I think the book will kind of show you both ways. They're good about, or Alex is good about showing you this one. They give you two options. You can either take these problems that you have and rewrite these two things with the common denominator and combine it together so it's one fraction, do the same thing on the bottom, combine it together so it's one fraction, then do keep, change, flip. Okay, you can do that. Or, here's the easier thing to do. Figure out what your least common denominator is first. Which for these shouldn't be too bad, right? Because you got x plus 8 in this denominator, you've got x plus 8 in this denominator. So for this one, that's going to be x plus 8. And then for me, just, here's the part I kind of like to do with this one. I'm going to multiply all the terms by the LCD. And then once you do that, then you just factor and cancel. Okay. And to me, that's a little bit easier than rewriting it, because when you start to go rewrite fractions and get them with their common denominators, and then you start adding the tops together, and then you've got, sometimes you lose a little bit. So this is one, and this is actually something that'll lead into what we do in 7.6. That once you find this least common denominator, so we've got the x plus 8. Go back and multiply every single term by x plus 8. And if you want to, go ahead and put that x plus 8 in parentheses so you know it's the whole thing times x plus 8. Okay, so, and here's the big part that you want to look for. That now, if you do that, all the fractions that you had, the double part, the complex part of the fractions, it should go away, because on this one, it's just 5 times x plus 8. So we'll just do 5 times x plus 8. So 5 times x is 5x. 5 times 8 is 40. Okay, for this part, the x plus 8 cancels with this x plus 8. It's going to leave you with that 10. Okay, on the bottom, that x plus 8 cancels that x plus 8, leaves you with a 14. And then for this part, you've got just 7 times x plus 8, so go ahead and do that. You've got 7 times x and 7 times 8. Okay, now all the fractions are gone. I mean, you still have the one big fraction that's here, but now you just work on the numerators. You've got 5x plus 50. On the bottom, you have 7x and 70. I guess we should put one more thing up here. After you multiply everything by the least common denominator, then you just simplify, combine like terms, basically. Okay. Then once you've simplified, got this thing down here, now you're going to factor. Well, 5 and 50, you divide them both by 5. 7x and 70, divide them both by 7. Cancel out your x plus 10s. Leaves you with 5 over 7. Okay, and the only thing that's different with Objective 4, and we'll do 2 on this one, just make sure we got it, that in Objective 3, everything is, you basically have the same denominator every single time. So there's just that one thing that you have to multiply it out. Objective 4 basically is now you're going to have it so that you have 2 different denominators mixed in. But you'll still kind of go through and do the same steps on this thing. So for this one, we'll do at least, make sure we do at least 2 of these problems. We've got 8 over x plus 2 plus 1 over x plus 7. Actually, make that x minus 7. And that's over 9 over x plus 2. Okay, and you have just the 2 different denominators, so both of those 2 things would be x minus 2 and x minus 7. Okay, now again, you could go back and rewrite every fraction with those 2 denominators, but it's going to get kind of ugly in a hurry if you do that. So here's what we're going to do. We're going to take everything that we had in the beginning, can't quite do it like we did on the last one, and we're going to multiply by that new denominator. Or multiply by our least common denominator, sorry. Okay, and again, we'll leave the original part in black, and then the least common denominator, when we multiply by through, we'll put that one in the red so we can see it. Okay, but again, once you do that, all the fractions should cancel out and leave you with just whole numbers on each little part. This x plus 2 cancels that x plus 2. That's going to leave you with 8 times x minus 7. That x minus 7 cancels that one. That leaves you with 1 times x plus 2. And the bottom, the x plus 2's cancel, leaves you with 9 times x minus 7. Okay, so we've multiplied everything through by the least common denominator. Now you've got just a simple numerator and one denominator, and then just simplify each part of it. You've got 8x minus 7, so we'll do 8x minus 56. 1 times x plus 2, that's just x plus 2. And on the bottom, we get 9x minus 63. Okay, on the top, start putting everything together. We've got 8x plus 1x, that's a 9x. Negative 56 plus 2, that's a negative 54. And on the bottom, we do get 9x minus 63. Okay, and again, here's where you've got to fight that temptation that sometimes people want to cancel out those 9x's. But you've got to remember that once you've simplified it down, anything that's got pluses or minuses, they're stuck together. They're one term. So the only thing you can do is, well, you've got 9 and 54. You can divide a 9 out of that. That would be 9 times x minus 6. Same thing on the bottom. You can take a 9 out of that one. Make it x minus 7. So now you can cancel out the 9's. And you're left with x minus 6 and x minus 7. Okay, let's get you one more of those and then we'll take a quick break. Okay, sticking with the same pattern, same objective here. Okay, 5 over w plus 2, 2 over w minus 5, 1 over w minus 5, and 6 over w minus 2. Okay. Okay, now a little bit different from, it's the same thing, but if we just scroll back up for a second. No, I set up pretty much the same way here. Thought I had something different to it. All right, now if you want to on this one, this is one where we could rewrite it and have all the stuff here. But when we multiply by the least common denominator here, question, go for it. Oh, it is. Hang on. Yeah, thank you. That's supposed to be w plus 2 there. Yeah, if that sign hadn't changed, then we'd had a w minus 2, and that would make this problem a lot more complicated. Okay, so if you go to this one, if you multiply this term by the least common denominator, the w plus 2's would cancel, and just trying to save us a little bit of room here for writing. The 5 will be left over, the w plus 2's cancel, and then we've got w minus 5. Okay, if we take this term and multiply by the least common denominator, the w minus 5's would cancel. That's going to leave us with a plus 2 and w plus 2. Okay. On the bottom, if we multiply this one by the least common denominator, same thing, the w minus 5's would cancel. That leaves us with 1 times w plus 2. And for this one, we multiply by the least common denominator, the w plus 2's would cancel, and it leaves you with 6 and w minus 5. Okay, so if you want to do that, you can to maybe save a little bit of work, because, again, most of everything is going to cancel out. And then just go back and do distributive property. You've got 5w minus 5. That's 5w minus 25. W plus 4. On the bottom, it's just a w plus 2. And multiplying by 6, that's a 6w minus 30. Okay, so 5w plus 2w, that's a 7w. Negative 24 plus 5 is a negative 21. On the bottom, 1w plus 6w, that is a 7w. And then 2 minus 30 is a negative 28. Okay. And again, you've got to think about those two things being in parentheses with the plus and the minus connected. Taking out the Gray's common factor of 7 will leave you with a W minus 3. Taking out the 7 there, that's a W minus 4. The 7's do cancel. And so we finally get W minus 3 over W minus 4.